Hello students, in our previous session we had learned few properties of arithmetic progression. We shall take up another very important topic called as sum of the first n terms of an arithmetic progression. Here we have a question. Prove that the sum of n terms of an arithmetic progression represented by Sn, whose first term is a and the common difference is d, is given by s is equal to n by 2 multiplied to 2a plus n minus 1 into d. Suppose if a plus n minus 1 into d is considered as the last term, it is also represented as s equal to n by 2 times of a plus l. We shall prove this. Suppose S denotes the sum of first n terms of arithmetic progression a plus d, a plus 2d, and so on. The nth term will be L. It is denoted by a plus n minus 1 time of d. Hence, the term preceding the last term will be L minus D. The term preceding L minus D will be L minus 2D, and it can be continued. Let me consider sum of the terms. It will be a plus d plus a plus 2d plus somewhere we have L minus 2d, next to that will be L plus d, next to that will be the last term, which is L. Let me write this as equation 1. Let me write this sequence in a reverse order. So S will become the last term L, the preceding term L plus D, next is L plus 2D. I made a mistake here, it is not L plus D, sorry, it is L minus D. So it is L minus 2D plus so on till a plus 2d, a plus d, and a. This is the second equation. The second equation is same as the first equation, but I have written in a reverse order. Let me add equation 1 with equation 2. I'll be getting 2 times of s equal to the sum of these two is a plus l plus the sum of the next two terms a plus d plus l minus d. D will get cancelled. We will be getting a plus l. The next term is also a plus l. Like that, I'll be getting the last term also as a plus l. Here if you count the number of times a plus l is repeated, it is same as the number of terms in the given sequence. So I can write it as 2s is equal to n times of a plus l. If 2 is added 3 times, I'll write it as 2 times of 3. If 2 is added 5 times, I'll write as 5 times of 2. In the same way, since there are n terms, let me mention here because n terms. So I get s as n by 2 times of a plus l, or s as n by 2 times of this last term I'll write as a plus n minus 1 into d. So n by 2 times of 2a plus n minus 1 into d. We use these two formulas separately according to the type of the question they ask. Let us solve one or two questions for today's session. Here we have the first question. Find the sum of the following arithmetic series. First, is it an arithmetic progression? That I need to find it out. To find that, I have to consider the second term minus the first term. I'll be getting 8 minus 1, nothing but 7. A3 minus A2, third term minus the second term, 15 minus 8, that is also 7. A4 minus A3, which is 22 minus 15, I get it as 7. Therefore, this implies the given sequence or series is an arithmetic progression. Since it is an arithmetic progression, I can use the formula s is equal to n by 2 times of, should I use a plus l? No, I shouldn't, because I don't know whether the last term is given. Since the last term is not given, I would like to use the formula 2a plus n minus 1 into d. Here, I would like to substitute the first term as 1, the number of terms as 17, and the common difference as 7. Therefore, s will be 17 by 2 multiplied to 2a. It is 2 times of 1 plus n minus 1 is 16 into d is 7. So sum is 17 by 2 multiplied to 2 plus 112, because 16 sevens are 112. So the sum is 17 by 2 times of 114. It is divisible by 2 as 5, 7, 57. So 17 multiplied to 57, AB 969. This will be the sum of 17 terms. You understood why did I take 17 as n? Because they have asked the sum till 17 terms. If you want to check this result whether it is true or false, you need to continue this till 17 terms. Each time you will be adding the common difference, nothing but 7. Let me solve the last one more question for today's session. The question is to find the sum of the series 7 plus 15 plus 23 plus 31 plus 39 plus 48, so until 255. How many terms are there? It is not asked, but the similar question can be asked. How many? Find the number of terms of the sequence. They may ask. First, let me find out whether the given sequence is an arithmetic progression or not. For that, I'll like to consider second term minus the first term. It is 15 minus 7, nothing but 8. Third term minus the second term, 23 minus 15 is also 8. Fourth term minus the third term, 31 minus 23 is also 8. This implies the given sequence or the given series is an arithmetic progression. Here they have given the last term, that is an. It is given as 255. There are two methods it can be solved. I am telling you the first method. I am finding the number of terms and then finding the sum. So if I do that, here I need to substitute the formula a plus n minus 1 into d equal to 255. A value is 7 plus n, I need to find it out, d is 8. So I'll be getting 8n. 7 minus 8 is -1 equal to 255. So n will be 256 by 8. 8 3s are 24, 8 2s are 16. So 32 is the number of terms. Therefore, the sum is n by 2 times of 2a plus n minus 1 into d. So sum of 32 terms is 32 is 32 divided by 2 times of 2a, nothing but 14 plus n minus 1 is 31 multiplied to 8. Let me simplify here. Is 16 multiplied to 14 added to 248, that is 262. We get it as 4192. This will be the sum. This is one of the method. Another method is I'll use the formula S is equal to n by 2 times of a plus l. So the number of terms I have already found. It is 32 divided by 2. First term is 7, last term is 255. So directly I'll be getting 16 multiplied to 262. This product is 4192. Whether you use this formula or this formula, the result will be same, but then you need to find the number of terms. Unless this number of terms is found, you cannot substitute here. So number of terms has to be found before simplifying, and the result obtained in both the cases will remain same. Understood? Before winding up this session, I would like to solve one question from the textbook. Fill in the blank in the following table Given that A is the first term, D is the common difference, An is the nth term of AP. This is related to nth term of AP. So you must remember the formula An equal to A plus n minus 1 into D. Look at the first question. They have given A, D and N. We need to find An. An is A8, which is A plus 9D. So A8 will be equal to 7 plus 9 multiplied to 3. So 7 is added to 27. So we get the result as 34. So this blank is 34. In the next question, we need to find the common difference, and they have given other 3 terms. So this is for the first one. For the second, it will be 0 equal to minus 18 plus n minus 1 is 9 times of D. So positive 18 will be equal to 9D. So D will be positive 2. So the common difference is positive 2. In the next one, we need to find the first term. An is negative 5 equal to A plus n minus 1 is 17. D is negative 3. So minus 5 equal to A plus, minus, it becomes minus 51. So A will be 51 minus 5. We get it as 46. So the first term is 46. In the fourth question, we have n to be found. An is 3.6 equal to minus 18.9 plus n minus 1 time of 2.5. So 3.6 equal to minus 18.9 plus n minus 1 into 2.5. So this, when you transpose, it becomes positive. It becomes 21 plus 1.5. It becomes 22.5 divided by 2.5 equal to n minus 1. So it becomes 9. 9 equal to n minus 1. So n will be 10. So n value is 10 here. Let's see the last question for today's session. They have given all the values. You have to find the nth term. So nth term is A, which is 3.5 plus n minus 1 is 104 into D is 0. So the last term is 3.5. Can you guess what is the sequence here? It is 3.5, 3.5. How many times? 105 times. That's all for today's session. We shall solve some more questions and then take up NCERT exemplar questions. Thank you.